Okay. Well, I think I can get started on the solutions here. This first, or you're going to help me, of course. The first one. What can we do to reduce this?
21 is 7 times 3, and 28 is 7 times 4. 7 goes with 7, and 3 is 4.
Oh, it's pretty fast. 5, 4, 2. Let's check. The top part's okay, right? Yeah. And the bottom, what do you want to do with that one?
4 times 7.
4 and 7 from Zoom, 4 and 7 from class. Yeah, we can do that. We could also go right to primes, which would be 2, 2, 7. Okay, but I think I'll stick with 4 and 7, because what are we going for? What do we want to see when we do this step here? Yeah. 7 and 7s, they're the same, right? So when they're the same, they'll divide out and they're gone now. Okay. So 7 divided by 7, gone, equals 1. And we're left with, yeah, 3 over 4 or 3 over 2, 2 if we did it that way. And then final answer is that for sure. Nice. Good, good. So to go from here, we have to factor and then divide out, right? Factor and divide. Good. The second one here. What do we do there?
11 minus 5 is 6, and 8 is power of 6.
Why is this minus? Because it is actually. Okay. What happens here? You got 11 X's all the way across. Here you got 5 of them all the way across. Cancel them out. How many you're left with? That's right. The 5 will cancel out. 5 will divide out. And so you'll be left with 6 that are there. Is that okay for everyone? Yeah? Okay. Now this one here. This is why, just hang on there. This is why I gave the question, because some people during the quiz, they subtracted these and we get like 7, and 21 minus 28 is 7. Doesn't work like that. What happens is the fractions, the numbers get reduced, just like here. And these X's, they subtract. Okay. Got to keep them straight. So these ones are, they reduce, these ones subtract. No subtraction with these ones. Okay. So what do we end up getting? 3 over 4 for the numbers. Why? Because of this number 1. And with those, we get X to the 6 like that. Perfect. Yeah. Okay. So with some of the homework I gave back, yeah, this actually came up in homework, not on the quiz. Some of the homework, check out this type of question. If I circled it, this is how you do it, okay? Reduce these numbers, exponent rules for those ones. Okay, part of what you got to do today. If it's a 5, let me redo a question here. You tell me what to write down. What's your question? 21? Oh, perfect. Okay. Yeah, that's right. X will be 1 because as a middle step, I'll show you this. subtracting because we're dividing. And so that will create x to the 1. You can write it in there. But then what happens? We never write it in there. We just go 3 over 4, x only like that. Okay. Oh, and that reminds me of a second question. I'll mention it today and hopefully I'll remember tomorrow as well. If you had something like this, okay, there's an invisible 1 there. So what happens with that invisible 1? All right, so watch. Plus 8, you get 9. Some people left it at 8 for some reason, multiplying or something like that. In the homework, I think, not on the quiz, but okay. So remember, if there's an invisible 1, you can write it in there and then keep track of it along the way. That'll get you places. Yeah. Okay. That was a nice little intro warm up. Let's see. What we got here for the next part? We're going to move on with our lives. A bit of a day ahead of us. We got take a look at something called polynomials. And those are just, for now, you can think of as big equations or big expressions. And you'll see a bunch along the way over the next couple of days. Today we're going to be adding and subtracting them. Now, in order to get ready though, you got to be able to work with integers easily. Okay, not to be silly, but what's 2 plus 3 equal to? I know, someone in class goes, huh? They can't believe I'm asking such a question, but it's true. What's 2 plus 3 equal to?
5.
5, right? Yeah, nice. Now, to make it a little more mysterious, what's 2 minus 3 equal to?
1.
Minus 5.
Ah, see?
Oh, minus
3 different answers. Yuya, what did you get for this one? Minus 1 indeed. Okay. Now, a useful way to think about this is a set of stairs. This is like ground level. This is one way. Ground level. The first number is where you start. Okay, so this starts 2 above. It's plus 2, an invisible plus. 1 stair, 2. That's where we are. And then this says go down by 3. Okay, so I go down by 1. I go down by 2. I go down by 3. Where am I now? Right
minus
there.
4.
Exactly, at minus 1, okay? If you don't like stairs, you can have a ladder on a house. Ladder goes underground. Okay? But this is not a bad model, not a bad picture for this type of question. Okay? Let's try these ones. What's minus 5 plus 7 equal to? Keeping this picture in your head. What's that? From class, we got 2. Got a minus 2 from class.
2.
Got a 2 from Zoom.
2.
Another 2 from 2 2s from Zoom. Okay, let's take a look. If we start at, well, if we start at minus 5, so we're down by minus 1, minus 2, minus 3, minus 4. We're at minus 5, right? Then we're going up by 7. Okay, so we go up by 1, 2, 3, 4, up 5, we're here. Up 6, up 7. So compared to the ground, where are we now? Yeah, we're up by 2, or in other words, we're at positive 2. Okay. Not bad. Now, so what you see on the screen, this might help. These are different situations that can come up. Okay. The first one in red, you're adding two positive numbers together. What's going to happen? You get a bigger positive number. 2 and 3, you get a bigger positive there at 5, right? Here with negatives, I haven't shown you yet. Yeah, but let's say you start underneath, you're negative, then you go down. You ended up even more negative. For this one, if you have a big plus and the small minus, you stay plus, right? Yeah, from class.
There is a problem here that minus plus it's minus the second one.
This one?
Yeah,
Yeah.
because it can be like this.
From class, we're commenting about this one here. If I click the screen, this one here, right? Not bad. What does this say though?
Okay.
That one's okay, right?
Yeah.
Yeah, good to check. Okay, so this picture might be useful and I'll have it in, I don't think there's a need to copy it down. I'll include it in your, on the Teams outline there. But we can try a couple of these just to see that it works. Let's say we have -3 plus -2. What's that going to be equal to?
-5.
-5 from class, -5 from Zoom. Yeah, let's check. We start here. So we start, there's the ground level, down 1, down 2. We start here at -3. And then we're going to go, look at that, down by 2. So we go down by 1, down 1 more. And where are we now? -5 indeed. Okay, we start here, go down by 2, down 1, down 2, and there we are. Okay, now I got a whole page of these coming up. I think even the next slide. So we can get a good practice here. Now, an important relationship that I want you to see, I want you to be aware of, is that if you subtract a negative, something very special happens. Yeah, the negative, what happens is they undo one another. These subtracting a negative is the same as adding them together. Okay, I'll give you that for free. This is like going down in the negative direction. So you go down and then you go up. It's kind of a funny word game you can have with this. But math-wise, yeah, something to remember, okay? See if some eyeballs are squinting there. This says subtracting a negative. Subtracting a negative. Okay, good work, Zoom, there, by the way. All right. So let's take a look at the next slide. Let's see what it is. Yeah, just as I thought, whole bunch of questions. Class, can you see these okay? Yeah, not too small?
Yeah, it's fine.
Okay, yeah, Zoom, you got the premium seats. This is like hi-fi quality in your living room, I bet. Here in class, it's a little, a little different. You got to watch with the sizes and such. So let's go in order across. We got 1, 2, 3, 4, 5, 6. Let's take a look at those first ones. Number 1, I'm going to ask individual people. Yeah. What's that one going to be? That one? You got a minus of a minus. I don't know if the light is in the way, or do you want me to write it here? You got 3 minus 5. Okay, so that makes a difference. Yes, equals 8. That's number 1. Number 2, Parcel, what do you got? 15? Oh, look at that. 8 plus 7. You lucky. Got one of those. What's next? Dunya, what's this one? That's right. Break out the fingers and toes. That's what we got them for. No, it's 15 plus negative 8. Do you need me to? I think I might have to make it bigger. 15 plus negative 8. $15 plus 8 would mean, think of the stairs, all right? Yeah, if it was 15 plus 8, it would be 23. But it's 15 plus minus 8.
Mhm.
No, it won't be. If it was 15 plus 8 only, then it would be 23. But what does a negative do? Yeah, it's 7. Okay. You're 15 steps above the ground. Then you're going down by 8. Yeah, perfect. See, this is why we're spending a little bit of time on this today, because this part has to be pretty comfortable. Number 4. Where are we at here? Zoom. Alicia, what do you got for this one?
For number 4,
Yeah.
minus 7.
Minus 7 indeed. 5 steps above, and then you go way below. Right on. Ideal. Number 5 there, what do we got? Hadil's keeping it secret.
Oh,
Someone.
-6. Sorry, I forgot to look that. Mute.
Oh, okay. They're both minus. Okay, so this one you're below by 2, and then you go down even further. No,
-10.
minus 10 it is. Yeah. You can always draw a picture. Okay, watch. I've been drawing stairs. So this is ground. So you go down by 2. That's where you start. Now we're going down by 8 from there. Down by 1 more, down by 2, 3, 4, 5, 6, 7, and careful with your picture. Down by 8 now. Okay, so where are we? Down by 1, 2, 3, 4, 5, 6, 7, 8, 9, and we're down by 10. Okay. Now, if I go back to the earlier page, it shows some of these different situations. Maybe you like this nicer. Yeah, you like this better? Yes. Now we have 2 sisters fighting one another, right? One likes this and the other one the other one. So what am I looking for? This one. It's a bigger minus. Look at the size. Look at the size of the circle. Okay. I think I can do this without, yeah, I can't. If you look at the second line here, you have a small negative in blue, small negative in blue. Okay, it's a big negative in blue. So look, you got a small negative in blue. That counts as a smaller one in blue. Makes a bigger one that's negative then. Yeah? Okay. So part of your, what you guys got to do is figure out what strategy you like. Stairways, colors, situations, right? And then use those. Okay. So those are all available. I don't think they're homework yet, but I might have some people do some extra practice there. Now, this is grade 10 stuff now. Okay, we're going to start doing some algebra, start writing, finding some shortcuts, just like we did with exponents, and then doing some adding and subtracting and stuff. Okay, from class, we got a question already. Yeah, go ahead. The answer?
What's in the English? What's without this one?
We got an English question coming up here. Picture on the board. Oh, that one. Okay, kind of, yeah, good. So it's a bit out of order from what we're doing in class, but interesting though. And if you know it, we can have some fun with it. Okay, if we have 2 times 3, that gives 6, right? If we have 12 divided by 4, what do we get? 3. Nice. Just for fun with what we just did, if we have minus 2 plus 6, what do we get? Nice. And now this is like the very last question, the 2 blues. Let's say we have minus 2 plus minus 12. What do we got? 14, yeah. Okay.
14.
Nice. Okay. So we have plus, dividing, oh, adding. I guess we can have subtracting too. Okay, this one will be a workout for you. Minus 3 minus minus 7. Don't hurt yourselves. What happens with these first? Plus.
And minus 10.
No, it's not minus 10. Do a little conversion first, okay? These two switch to a plus. And so you start 3 feet under, and then you go up by 7. So where are you?
Is the answer 4?
Yeah. Zoom got it. I think you did too. No, you're going up. I can go back to the blue if you want. That'll be this one. Small negative, a minus 3, and a big positive, a plus 7. Okay. Or you've gone 3, you're under 3, so you reach the ground, and then you go a little bit more. Plus 4. Okay. Now, someone in class was asking me about this now. What is this exclamation mark? Doesn't mean 5. It's not an exciting 5. Okay. But it is another math operation. And how it works is you start with this number. Yeah. And what comes next from class?
4 times 3 times 2.
Okay. So you start with the number you see, times all the way along, always down to the number 1. Okay, and then you work it out. And that's 12, 20. This is 120, I think.
What's the name of this?
Yeah, I'm not going to tell you yet. The question from class is, what is the name? top secret still. How does this one look? Yeah, see, it starts at the 3. Everything down to 1. This is like grade 12-ish stuff in a way. We can do some. Let's see, you guys are
We studied this in grade 8
grade 8?
Yeah.
Grade 8 in Iran. Yeah, I know. That's how it works sometimes. Okay. So multiply these all together. Okay, I think this happens to be 6. This happens to be 20 times 6. So that's 120, right? What is this called? This would be 3 factorial is how you say that. Okay.
We say factorial.
Oh, yeah? Okay. So in class, they're just asking what's the word for this? Random question in the brain, right? It's how learning works sometimes. And so yeah, this would be 5 factorial, means multiply everything all together. Okay. Useful for some special questions in math that yeah, we won't see for a little while. Okay, but we'll have some fun with this. But now getting back to our polynomials. Okay, we have all of these things, all these 6s there. Now, just like last day, we talked about there being 200,000 cars right out on the road. Okay, imagine writing 200,000 6s. It's going to be there a while. So there's got to be some shortcuts going on. All right, so there you go. How many 6s are there? There's 5 of them, so you just write 5 times 6 instead, right? Now what happens is we update it a little bit. We say, okay, let's say we have a bunch of x's there instead. Now it's algebra, right? And just for fun, I'm saying each x represents 1 banana. Yeah, so how could you rewrite this expression? 5 times x, right? And you could say it in English, oh, this means actually 5 bananas is what we're deciding to talk about in this particular question. Okay. Now, super important for today. If x is banana, what does x squared mean? No, that would be that'd be 2 bananas like that. 2 bananas. 2x like that. This is banana squared. Or banana to the power of 2. My point is banana the same as a banana squared? No, right? I would eat a banana. I wouldn't eat this because I don't know what it is, right? So it's a cute way to remember that these things, x's and x squareds, they are different from one another, okay? They both have x's in them, but the exponent up there makes them different, and that's important for today. Okay, now maybe even on the next slide. See what we got here. All right, so this comes up in a little bit. Okay, still some algebra stuff. We have 3x over here plus 2x. Okay, everyone's okay that this equals 5x? Collect in like terms. Okay, because you can do it long way. 3x is like those. 2x is like those. Notice they're not multiplied like the exponents. They're added together. It's different. Okay. But notice what we get. We get 5 of these things. So we get 5 there. And they don't change. They stay as x's. They don't turn into x to the power of 5 or anything. They stay as the x's that we see. Okay. Just for fun, I threw this plus y in there. Okay, we have the same things from before with this extra y now. So if x's are like bananas, y is like an apple, right? So what do we got? We got 5 bananas here, 5x, plus 1y. One other thing, plus 1 apple, let's say, right? Can we combine those any further? No. not by making juice of some sort, but that's not what we're going for, right? You got five of one thing, one of the other. Okay, what we got here are some words that you need to be aware of. Down at the bottom there, it says it shows 2x and 3x. So for the 2, that is the coefficient. And for the x, that is the variable. So we can combine terms when the letters are the combination of letters are the same, combination of variables. Okay, and then we just keep track of the numbers in front, just like we did with radicals. Do you remember that? Yeah, see? When they're the same, we can combine them. When we have a root 5 and a root 5, yeah, we can combine those together. However, if we have a root 2 and a root 5, done. No more. Nothing else to do. Right? Okay. Let's look at these ones. Both y squares, right? Okay. So if we added those together, what would we get? What was that? Ah, no, actually. What happens is, I'm saying just first of all, the point of this slide is to say that because they are the same, now we can combine them together. Okay, so that's the point of this. Just for fun, I'm asking what happens if we add them? Okay, so there we go. So I'll say it again. Yeah, from class we got to figure it out here. The y squared will stay the same. No change there. But we have 2 over in this part, 6 over there. How many in total? 8, right? Yeah, exactly. Okay, so today you're going to see some complicated versions of, not complicated, longer. That's it. Okay. Notice these ones, they're just numbers, no letters. So they count as the same, right? Those will combine together. Just for fun, what is minus 6 plus 4 equal to? Minus 2 it is. You're down by 6. You only go 4 up. You're not quite back at ground level yet, eh? 2 below, 2 to go, right? Okay, good. Next, these ones, see, different letters, right? They're not the same. We won't be able to add or subtract them from one another or simplify them. Okay. These ones, got to get a good set of glasses. Okay, the exponents are not the same, so they don't count as the same. They are different. Okay. All right, so check out this one. Collect like terms. That means if the letters are the same, we can combine them together. Okay, so what do we got for the x's here? Let's see. Yeah, for we're getting some an answer in class. For all of these, you want to keep track of the sign in front. They go together. Okay, so watch this. It shows up there's 4x, and then a minus 3, and then a plus 2x and a plus 2. Okay, so here's a trick. You see how that's an x and that's an x? Give them the same underlinings. You see how this is a number and that's a number? Give them the same underline there. Okay. These will combine together and those will combine together. Okay. So if we have 4 x's and we're adding on 2 x's, how many do we now have altogether?
6.
6 indeed. 6 what? 6 x's. Okay. Actually, I was talking about bananas, but a cute thing might be dogs in the park. 4 dogs over here, 2 dogs over there. How many dogs are there all total? 6 of them, right?
Mhm.
Importantly, they stay as dogs. They don't turn into dog squareds or anything, right? That'd be a weird animal. Okay. So if it's x's here, it stays as x's. Right? Over here with the numbers. Down by 3, up by 2. Where are we at? -1 from -1 from class, yeah, and from Zoom as well. Okay, good. So this is the sort of thing we're looking at today. Just gets busier and a little fancier. See, how about this one? I'm just gonna write it down, give you guys a chance to try it. This one here, 8x plus 2y minus 3 minus y plus 7. Okay. So the trick, underline them first, okay? And if they're the same. We have an x here. Okay, that's the only x. Nothing going on. We got a y here. Y here. Those ones will get together. Those ones will combine. You got a number here. A number there. Those ones will combine together. Okay. So looking at the x's, what do we got? 8x only. That goes like this. What about our y's now?
-3.
Minus 3 is correct. Yeah. -3 along with the y that's there. And for the last part, see? Imagine it's your legs doing this. You walk down 3 stairs. No, you're down 3 stairs. Yeah, and then you walk up 7. Plus 4. Okay. All right, so this would be when you collect like terms, this is what you get for that first, for this expression here. Okay, good work. Now, all this that we were looking at comes from adding, subtracting terms from one another. This one involves some multiplying. Okay, it's a special way to multiply numbers together that comes up in math a lot here. Okay, so what are you looking at with this sort of picture? Well, you're looking at something like this. If you have A, it says A and then B plus C like this. This is like having 2 times x plus 3. Yeah, from class we got the answer. Someone knows this already. Nice. What we do with some style as we take the number out in front, we multiply it by that, the first term. So we do that, we get a 2x. And then we do it again. And that 2 times the next thing. And now you got to keep track of all the pluses and minuses along the way, okay? This one, it's nice. Everything's positive. Okay, we got a 2 times a 3. That's a plus 6 like that. Right? Okay. So what can happen is these can be long, more than one term there. Gets a little bit busier. Whoops. Right? It's like that. Now, what it shows here is that you take the number in front, you multiply by each thing, and this is what you get on the right-hand side. A times B for the first numbers together, and then A times C for the next ones. So you're getting some algebra there. And the goal is to just show that the left side is the same as the right side using these numbers. Okay, so what we'll do instead of using these, I'll go back to the screen that you see there. A is equal to what? 5. B is equal to what? 4. And then C is equal to what? 2. Okay, so on the left-hand side, LHS, we have A times B plus C, right? So A is going to be 5, B is 4, and C is 2. With orders of operations, you officially do what's inside the brackets first. So you do the 4 plus 2, that gives you a 6. Final answer, 30 for the left-hand side, okay? Now we're gonna do the same with the right-hand side. Right-hand side, when we multiply the numbers through as you did, it actually ends up being A times B plus A times C like that. What was A? A is 5. What is B? 4. Just going back up here. 5, 4. We got 5 and 2. Okay, so we work this out. A little different, but should end up being the same. Let's see. 5 times 4. Earthquake in Zoom. 20. Yeah, good. 5 times 2. Nice. 10. Final answer? 30. See? So that means the left-hand side is equal to the right-hand side. That means telling you truths, not telling you lies. This thing is the same thing as AB plus AC like that. Okay. Now, there's another way of looking at this that uses a picture, and I consider it pretty important. So watch this. If you have a square like this, I'm going to say that, what was this? This was, I'm going to say this is side 5 and this is side 6. Then the area on the inside, well, because it's a rectangle, believe it or not by the picture, if you allow it, right? How do you find the area of a rectangle? Top secret, not telling me? Length times width. You go length times the width. So the length is 6 there. Width is 6 times 5, right? So you get 30. True? Okay. So another way to think about this, and suppose that's 5, but suppose it's split up. Suppose this length here is 4 and this length here is 2. Yeah, 5 times 4, 4 times 5. It's true. 2 times what? Nah, length times width. So length times the width there. Mm, let's check this out. I'm going to redraw this again here, this situation. Got it like this to start with. I'm saying that this length here is 4, right? This one's 2. And that's 5 there. So to find the area of the whole thing, that's the goal. Watch, you can split this into 2 separate parts. That's a 5 and a 4, and this is a what? That's a 2 there. How long is this side got to be? No. That side there is 5. See, 5 across, right? No. If this length is 5, then when I put it over here, that length is 5. And that length is what? 5 as well. Right? It's like how, like your yard or something like that, right? So your house, the front of your yard is 5. So this part is 5. That length is 5 in the back, right? 2 separate pictures now in one, right? Okay. What's the area of this one? $20. Yeah. You get it from 5 times 4. 20. This one? 10. So what do you get when you add these up? This area plus this area? 20 plus 10? 30, right? See, so you can do it all at once, or you can do it separately. That's kind of what this thing is. You do it all at once, or you do it separately. See? So you got these pictures now related to the equation that's there. Beautiful. All right. Yeah, sure. Backing up.
AB is A times B, right?
AB is A times B, yes.
But what can we write when AB is like 11, A is 1, B is 1, 2, something like that.
Let's see. We had a question from class about A and B being multiplied together.
I think I write it.
Okay. Yeah, I was going to put it on the board and we'll take a look. See what we got. B is 3. A is 2.
And to be like not AB, there is something here. A is 2 and B is 3 is 23.
Okay. So, yeah, good. From so AB, I'm going to tell you, for us means A times B.
Yeah.
Okay, so if A was equal to 2, B is equal to 3 as was said in class. We have, watch this, just how the symbols work, right? 2 times 3, we get an answer of 6, right? Okay, but now, this is a separate situation. The number 23 has a 2 in it and a 3 in it, just like this, right? Okay, here's how you can write the number 23. This number 23 actually means 20 plus 3, right?
A plus
Not bad. We're getting there. So A is 2. There's a 2 there. 20 is the same as 2 times 10 plus 3 now, right? Okay, so I'm not asking you to invent this. Just go like, yeah, okay, this 23 is the same as that, following it along, right? That makes sense. Okay, my job here to invent it for you guys to see. So now we have a 2 here. We got a 2 there. So that's like A times 10 now, right? Plus the 3, which is the B, right? And then usually the number's first. So I think you might have something like this. 10A plus B. When you have A is equal to 2, and then B is equal to 3, this thing will give the 23 that you're talking about. Okay. All right. You won't see this unless you do some math contests, and right. This is more what we're talking about. Whenever you see A and B like this side by side, it means they're multiplied together. That's the big thing for you to know. Okay, well, let's see what else we got. It's pi time. Just a little bit. Oh, okay. Let's do this one. What do we got? On your marks, get set, go. Yeah. From class, I'm hearing good things. This is what we got. I call this the rainbow because it kind of looks like one, except that it's all green instead of different colors, right? But you go 3 times the first thing. So what do you get?
3x.
3x for sure. You get now 3 times the next thing, which is 12. Okay. And so plus 3 times plus 4 is plus 12. Okay. So what we got is 3x added to 12. That's what we get as our final answer. Okay. It's not 3x times plus 12 to give 36 or anything. It doesn't work that way. Okay. Works like this. And keep in mind, you can always do a little rectangle picture. Okay, we got 3 for the this side here. We got x and we got 4, right? So what's this area in here? 3 times x. What's that area in there? Yeah, officially 3 times 4, or directly 3 times 4, which now is this area plus that area there, right? So we get our answer like that. Pictures are useful. Right? That's one example there. Okay, oh, look at that. All worked out ahead with some effects. Okay, there it is for you. Okay, yet another symbol for time, the asterisk, just because done on the computer this time. All right, and go on to the next one. Yeah. And see what happened? Too fast? You saw what's coming up. So got to get your negatives and positives ready, okay? All right, negatives and positives ready. You got negative 2 now times plus 2x. What's that going to be? Mystery.
4.
4 for sure. I'm just trying to decide if it's plus or minus. So negative times a positive is what? Good. Negative times a positive is negative. Okay, so this will be minus 4x from those ones there. Okay, next. We got -2. Look at this. We got to include the -3. It's a little trick, actually. Okay, but we're good. That's how we're going to do it.
Minus the 6.
Multiplying. Okay. So we'll do the numbers first. What's 2 times 3?
6.
Zoom got it
No,
right. 6.
Yeah, 6.
Oh, you did? I couldn't hear. It's in the mask. Okay. I thought someone said 4. I'm like, what? 2, 3, 4? That's not how it works. Okay, we get 6. But now watch. Negative times a negative. Yeah, plus. Okay. We don't have big, not like the earlier slide with the red and the blues. Okay, but still kind of that level. You gotta know that. -2 times -3 plus 6. Final answer. Okay. Now watch. Any like terms there? No. That's an X. That's a number. No like terms. It's finished there. Okay. New style question. Look at this one. Like term, remember, it means we have 2x plus 2x and a 3x. Those we can combine those because the letters are the same.
X
Right.
becomes minus y plus x.
For this one here,
Yeah.
no, we do the rainbow again. Do one of these. Yeah, that's what I'm gonna do. We got -4 on the outside. Y is first. That's kind of weird. Usually it's in alphabetical order. So usually X would be first, but this question is just like that.
Minus 4y equals out. Plus.
Yeah. Zoom got the first part right. This broke up for the second part.
Okay.
No. There's an invisible 1 in front of both of these. So this Y means a 1Y. This X means a 1X. Oop. Marker's dying. Huh? Yeah, okay. So from class, we're doing, looking at this one. Numbers first, 4 times 1, 4. Absolutely. It's definitely what it is. I'll write that down. Okay, now is it a +1 or a -1? Plus. So minus times a plus to get the sign. Minus, yeah. Okay, so it's minus for the numbers that we got -4. And look at this, we got a y hanging around there, right? Okay, so -4y will take care of our first part there. Okay. The next part is this. That one. Four times 1, 4, yeah. Minus it is because it's a plus and a minus. So -4. Then X, that's right. Okay, and don't forget, we can do it like this. -4, that's a Y there, and it splits up. That's the X there, right? So what's the area of this first part? Length times the width. So -4Y, yeah. And what's the area in there? -4x. Length times the width, right? And then you combine those together. You add these areas up, right? So officially, watch. It's that area plus that area there. Okay. Now, no, we can't because we have a y and the x, so those keep them separate. No. You have -4 cats and -4 dogs. Okay, they stay as separate things. You don't get a dog cat or a cat dog. Okay, but what I want you to notice is that this plus adding a negative like this, that's the same as subtracting, okay? Adding a negative, that ends up being just subtraction like that. Okay. What next? Well, similar style, you know, just pluses and minuses again. What do we get for here? -8 for sure. -8x for the first part. Yeah, absolutely. I'll write that down. See, so -8x, absolutely.
Plus
Because
4.
12 for sure, y for sure. I just don't know if it's plus or minus yet. Maybe you guys can help me out. 12 for sure, y for sure. -4 and a -3. So I think Zoom got it. Plus. Yeah. Because a negative times a negative will be a plus. Yeah. Nice. Okay. Let's see. Hope these questions start getting a little harder. Oh, yeah. Well, this one a little bit. Because now what happens? You have to start remembering your exponent rules as well. Okay. So for the first part,
6, x2.
we have x2 from Zoom. Yeah, Zoom, you're right. X to the power of 2 is the answer. So watch. I'll show in this way that I haven't shown you yet. So you do the first part. I'm going to show it like this. You get 2x times 3x. Okay,
And 6.
nice. Zoom says 6, which is 2 times 3. Zoom says x as well. But notice, you have x times x. 2 of them, right? Okay. Invisible 1, invisible 1. Add them together, you get 2. Other way around. When you're adding or subtracting, they stay the same. When you're multiplying them, now they change. Okay. Okay, because look, we x times x, so what do? We add the exponents together. So 1 plus the 1, 2. Okay. For the last part,
8.
8 for sure, plus or minus,
Plus.
positive or negative,
Minus.
negative. Yeah. And this one has an x there. Okay, so 8x like that. Good. Okay. Minus 8x then. Okay, so yeah, just bringing exponents in there a little bit. That's going to happen. What is this? You know what? These are the words for what we were just doing. So this rainbow thing is called the distributive property. That's the official name. And we are eliminating the brackets when we do this. Here we got the bracket here, bracket there. Multiplied through, brackets are gone. So that's step number 1 there. Next is you combine like terms. We haven't really had that yet here. I think in the couple of slides we will. We'll have to do this and then collect like terms. Okay, and this last one, this just says make it look nice. Honestly, that's what it says. Alphabetical order, X, Y, Z. And that's good enough for now, actually. Okay. Constants at the end. See? So this one gets a little fancier. We got that 2x out in front. That makes this question a little different than the earlier ones. So I'll show you how this one works. We got a 2x, we got a minus something, minus 3, and then a 2x minus 4, okay? So watch, the rainbow is not going to include the 2x here. There's no brackets around these, so it's out in front and separate. So that just gets written down. But the rainbow is going to come from the minus 3 now, being multiplied by each term on the inside of the brackets. Okay, so we're going to have minus 2x with a minus 3 times this 2x. And then we'll have a minus 3 times the minus 4 that we see there. Beautiful. Pluses and minuses. 2x there. This next term, what do we got?
Minus 6.
Minus 6 along with the x, yeah. Okay. Oh, along with the x. Okay. Over here, what do we got?
Plus
12.
12.
Plus 12 for sure, from everywhere, yeah. Nice. Okay. So this is just like before, right? Except for the 2x there. But now what we got to do is we got to check over our result and see if there are any letters that are the same, any like terms. And there are, right? How do we do that? Remember, underline them in the same way. So that is the same as that. And then that one's different, right? So it gets a different signal there. Okay, so breaking out now the integers. Look at that. Using everything for this. Whew. I heard a minus 3 from class. I don't know. Up by 2, down by 6. Yeah, minus 4 instead I'm hearing. That makes sense to me. Minus 4 what? We're looking at x's, so minus 4 x's. Plus 12, that just hangs around. Okay, nothing to combine with that one. Finishes there. See, look at this. Starting to look pretty professional, eh? Let's try this one. Oh, what is this? This is just showing that the exponents stay the same. You see we had x's all over the place, so it stayed as x's. Now we got x squareds all over the place. So they stay as x squareds. That's what this slide here points out. And useful when we start getting fancy questions like this. Okay. If these were all multiplyings, if we were timesing these all together, and no, it doesn't stay as x squared. Start adding all the exponents up. Okay. Okay, we saw that before. So like terms we saw before, now they're just highlighting the fact that they have exponents now. We're focusing on the exponents to make sure that they're the same. X squared and x squared, like terms, x squared and x, nope. Different. X, tiny writing for class here, x to the 4 and x squared. No, not the same. These ones are. Okay. So you can see, just work them out in the regular way. 3x squared, 2x squared. Uh, 5x squared, like that. 4x to the 4, take 3 of those away. X to the 4. Last one's for fun. What do we got? You got an arrow in the way is what you got. There we go. Now it's a little nicer. So we have 10 to start with, and then we get 3 more. So how many do we have? Yep, 13. And then we get 8 taken away. So how many are we left with? 13, I think, but yeah. 13? Yeah. Yeah. 13 minus 8. Yeah. Good. So 5. What? X to the power of 4s. That's what we're looking at for this particular one there. For that last one. Okay. Yeah. Yeah, you will. It's on Teams. Homework is on Teams. Let's see how much I have left here. What do we got? This just highlights the highlights the exponents that you have, exponent rules you have to use. Oh, yeah. So remind me, what's the first one? X times x to the power of 2 times x to the power of 3. Yeah, 2 plus 3 there. So that will be x to the 5, right? Yeah, looks good. The next one. If it's a weird symbol, it counts as times. All the other ones are pretty ordinary, but times can be different things. So this,
6 x.
not bad. We got the 6 part. Now we got to worry about the exponents. So watch this.
Exponent will be 3.
3x squared. So 2 times 3, that gives 6 there, right? Now
Yeah.
that's the invisible 1. So the exponents on x will be,
3.
add them up, 3. Yep, add them. When multiplying, add the exponents. Final. Yeah. Oh, even one more. What's this one? Yeah, x to the power of 4. Okay, 6x to the power of 4 for that one. Yeah. Okay. Beauty. See? So you guys make these longer. And you got to watch the like terms carefully. Yeah, so remember, you can write it all out and use special underlinings for each of them, right? 4x squared, I'll give 3 of those. 4x squared minus 3x, I'll give something like that. Plus 4x, that's another x thing, right? That gets one of those. 2x squared, oh, an x squared, we've had one of those already. 3 of those. Just helps your eyeballs a little bit there, right? And then a minus 2. Okay, so for the x squareds then, how many do we have?
6
6. We add the coefficients.
x x on power 4.
No, Zoom stays as x to the power of 2
3
because we aren't multiplying these things, we're adding these things. So if we're adding or subtracting, kind of counts the same, then it
Oh.
stays as x to the power of 2. Okay, that one looks good. The x's now. Down by 3. And then we're going up by 4.
Oh, minus 1.
Hey, from class, we got the correct answer here. Plus 1x.
Oh.
You're down by 3.
Yeah.
And you go up by 4, right? So you go up by, cancels that out, and an extra 1. Okay. The 1, I'm going to leave it off just because that's what we do. Minus 2 at the end. Yeah? Yeah.
How about plus 2 x2?
The minus 2, that's a number without any x's, right? So that means there's nothing for it to combine with. So it just stays the same.
Oh, yeah.
We just bring it down. See, a little fancier. How we doing for time? Oh, how many are those? Okay, got 3 of those left. Let's just do 1, I think. Yeah, we'll make this the last one. Oh yeah, for sure. It's the last piece of paper. You guys are lucky. See, so watching the exponents, watching the pluses and minuses. Let's try and do some good things for this this here. I'm just going to copy the question out so it all.
Minus 4x2 plus 11x.
Maybe. We got an answer from class. I'll write it down. What'd you get?
Minus 4x2
X to the 2, let's say. Yeah.
plus 11x.
Okay, we'll see. I don't know yet. What do you think, Yoya? Parcel right? Let's find out step by step. Rainbow.
We
No.
keep 2x on power 2.
Got a couple of things. Let's see. The rainbow, where's that going to be? Good. From here to there. And from there to there. The other numbers are just going to be, just bring them down. They're not involved with multiplying here at all. Oh, and that other green is so light you can't see it in class here. We got a second one going like this. Okay, so we got this 2x squared just coming down.
Six.
This minus 2, I'll show it as this for now, but minus 2 times 3x squared. And then minus 2 times, watch that, minus 4x. Plus 3x, bring that down. Okay, so let's do the multiplying and then we'll collect like terms. What does this thing become?
6.
There's an x. Or did you say 6? 2 times 3, 6.
Yeah.
Okay. It's going to be minus times a plus. And then it's going to be x squared as well. Okay, so it looks a little funny with the gap in there, but it's all one thing. Minus 6x squared. Over here, what do we got?
Plus 8.
Plus 8. Nice. Class got it. Plus 8x. With little help from Zoom there. It's good. This plus 3x, just bring it on down. See? So now like terms, and that will finish off this example here. Got an x squared and an x squared. What do these combine to?
4.
4 is part of it. Minus 4 for the sign, that's true. X to the power of 2, yeah. Stays the same, nice. Very good. Final piece right here. 8 plus 3, that's what we're looking at. Nice. It's going to be 11. It will be plus. And then stays as x. Just like that. And I might add, just like was said earlier in class, well done. Okay, good people. That was, wow, a long day. I'm gonna have to give you like a double break tomorrow. So what do we got? For class, I actually have some pieces of paper to give you for the homework. And for teams, as usual, it's, well, on Teams. So
Yeah.
you can take a look there. There are a lot of questions, so I'm gonna assign only a few of them as opposed to all of them. Otherwise, you're gonna be here till January. Okay, so I'll update the Teams postings in a couple of minutes, and class will get you sorted out right away. All right. So from Zoom, anything else?
For my quiz.
Yeah, good. The quiz I'll do right away for you and get it back to you.
Okay, thank you.
Yeah, perfect.
And the last